All right, welcome to the video for the last lesson of unit number 4, kind of an extension of what we've been working on in lesson 7, proving these triangles are similar to each other. So for the first question, it asks to determine whether or not these two triangles are similar in a state Y. So looking at these two triangles, I noticed that angle B is 50 and angle C is 60. So if I do 180 minus 50 minus 60, well, that leaves us with 70. So that leaves this remaining angle as 70 degrees. Well, if I do the same thing for S and T, so if I do 180 minus 50 minus 70, I'm left with 60 degrees. So what I notice is all three angles are the same. So I can say triangle ABC is similar to triangle RST by angle. For the next question, I look at this and I see all the sides. So one of the things that we noticed from the lesson today was that if the ratios are the same for all three sets of corresponding sides, then it's side-side-side relationship. So if I go from 5 to 2.5, that's half. If I go from 6 to 3, also half. If I go from 7 to 4, not half. So these are not similar. B is a similar question. Only weird thing about B, other than the fractions, is the triangles are kind of pointed in the wrong direction. So if I just redraw ABC so that AB is on the base, so I could keep 36 where it is. I just want to put C up here and A down here. So this is going to become 7.5. I like decimals better here, actually. BC is 5. I'm going to make this 6.25. And 9 3/8. I'm going to make 9.375. So now I'm just doing some comparison. So if I divide BC compared to DF, I get 5 over 6.25, which gives us 0.8. Well, that comparison should be the same as the other segments. So if I compare AB to DE, if I get the same ratio, I wind up getting similar triangles. So if I divide those two numbers, I also get 0.8. So these two sides are the same ratio, or they're in proportion. Also, I notice that I have an angle here that's congruent in between them. So I can say triangle ABC is similar to triangle DEF by side angle side. Because I have two sets of sides that are similar or proportional, and I have one included angle that's the same. Number D, this was a regions question. So it says in the diagram below, triangle ABC prime is the image of triangle ABC after a transformation. The only transformation that we know that changes size is dilation. So I could say this is a dilation. And it says explain why the two triangles are congruent. I can say because in a dilation, the angles remain the same. So the triangles, it's a weird looking triangle. So the triangles have three congruent angles. Angle, angle, congruence. Part E is kind of weird, and it's kind of having you think a little bit, which I know sometimes is hard for me to do on a homework question, but it's asking us to look at these two and see that these are going to be similar to each other. The reason why these are similar to each other is because there's only one segment to talk about. So the radius in any of these circles is always going to be a 3 or a 5. So they're proportional to each other because it's the only segment that we have. So one of the things we can say here is all circles, no matter the radius, are similar. It's an important concept that I'm hoping that you were able to develop. F is last question on the homework, and it's natural proof, similar to what we did in class, almost actually identical to one of the ones that we did in class. So I can call this angle 1 and angle 2. So angle 1 is congruent to angle 2, vertical angles. I also know that GI is parallel to NT, it's given. These two things are parallel to each other. So I can say GI is parallel to NT. I know it doesn't use the symbol, I'm going to, and that's given. If I look at one of the transversals, so like this transversal here, well, that one transversal is going to give us alternate interior angles, both here and here. Notice they're on opposite sides of that yellow line I drew. So I can say, we'll call this angle 3 and angle 4. So I could say angle 3 is equal to or congruent to angle 4 because of alternate interior angles. So there's my third bubble. And then I can say triangle GIA is similar to triangle TINA by angle, angle. Remember, in our proofs, I'm only ever going to use angle, angle. I'll never use anything else other than that. Hopefully this video helped, and I'm hoping that you're watching all of these. Keep in mind you do have a test coming up very soon, so make sure that you're starting to study all of your rules and things from this chapter.